Let's discuss some calculations involving Kc and Kp. Here we have an example where they are asking us to calculate the values of Kp and Kc at 1273 kelvins for the following reaction. They are telling us that the pressure of carbon dioxide in equilibrium with calcium carbonate and calcium oxide is 3.87 atmosphere. So the first thing that we need to notice is first, right, that the equation is balanced. In this case, it is. The other thing that we need to notice is the physical states of the species in the reaction. In this case, we notice that we have two species that are in the solid phase, and then we have one that is in the gas phase. This type of equilibrium, again, is called heterogeneous equilibrium. Okay, and when you have an heterogeneous equilibrium, we only put the species that are relevant for the equilibrium expressions, things like gases and solutions. So in this case, we notice that there is only one species, right, that is in the gas phase. Therefore, we couldn't write down the equilibrium expression, right, in terms of the that species. The question will be, should we start with Kp or should we start with Kc? Well, the way that we start at statement will depend on the information provided. In this case, they're giving us information about the equilibrium pressure of carbon dioxide, okay, in terms, right, of atmosphere, in pressure. Therefore, the only information that we have available, right, at equilibrium is information of the partial pressure of carbon dioxide. Therefore, we need to write down the equilibrium expression with respect to pressure. Again, the only species that we have in the equilibrium is carbon dioxide, so we just include that species there in that calculation. So in this case, the Kp value for this equilibrium equals to 3.87, with our units. Remember that the equilibrium value is a unitless number, and basically what we are saying that each pressure and equilibrium is normalized by a reference value. So now that we have the Kp, we can now continue with our calculations to get Kc. For Kc, we know that the relationship between Kp and Kc is Kp equals to Kc RT delta N. Okay, we don't know yet, right, if the Kp and Kc is the same. The only way to know, right, is looking at the chemical equation. And if you see this chemical equation, right, we have different numbers of moles in the gaseous phase. First, on the products, on the reactant side, we don't have any gas at the beginning, and then at the end we end up with 1 mole of of carbon dioxide. This means that our delta N equals to 1 minus 0, delta N equals to 1. Okay, so we're going to come back here to the expression. Remember that we're trying to solve for Kc. Kc equals to Kp RT, right, to the 1, okay, which is the delta N that we obtain here. I continue with the numbers, 3.87. The gas constant in terms of atmosphere times, okay, remember that the temperature has to be in kelvins. The numerical value of the Kc expression is 0.0370. Okay, and this is one of those cases, right, that the equilibrium constant in terms of pressure and concentration is not the same. And the other thing that it allows you to see which K value you're going to start with. In this case, information is provided to you in terms of pressure in the equilibrium mixture. So start with that, right? Because it's just the easiest way, and then you can interconvert between the two Kp and Kc using this equation.